fluid coding, and AI. Qwopus3.5 27B v3 has the kind of model card story local AI users want to believe: a 27B reasoning model, GGUF files, LM Studio support, and bold coding claims. But the local benchmark run in this report landed at 644 out of 2172, or 29.26%. That does not make the model useless. It does mean the interesting question is not hype. It is where the promise survived, where it broke, and what a local developer should do next. The question is not whether one run can rank every deployment of Qwopus. It cannot. The useful question is narrower. If you load the GGUF version locally through an LM Studio-style workflow, can this model act like a dependable coding and reasoning assistant, or does it need heavy guardrails? By the end, the answer should be practical. You will know what the model is positioned to be, what this benchmark actually measured, which parts looked promising, and which failures matter most for agent-style use. The public identity is straightforward. Qwopus3.5 27B v3 is published by Jackrong on Hugging Face, shown with an Apache 2.0 license, and listed as a 27B parameter model derived from Qwopus3.5 27B. The model card positions it as reasoning enhanced, with attention to structured reasoning, correctness, inference efficiency, programming, and tool augmented agent workflows. It also says the training pipeline used unsloth, supervised fine-tuning, and LoRa. That is a strong pitch for local developers. It is also a pitch, not proof, that every local setup will behave the same way. The GGUF side is why this model is interesting for local users. Jackrong's GGUF repository lists quantized files from about 10.7 GB at Q2K up to 28.6 GB at Q80, with a BF16 file around 53.8 GB. Hugging Face's LM Studio docs describe LM Studio as a desktop app for local AI models, built on llama.cpp and available on Apple Silicon, Mac, Windows, and Linux. That means Qwopus is easy to try. It does not mean it is easy to run well. The benchmark evidence here is a first-party local report labeled All Benchmark Suites. It covers coding, source research, quantitative reasoning, data interpretation, writing and editing, planning operations, and safety policy. That range matters because it is closer to how people actually use local models, not just one coding puzzle, but a mix of structured outputs, reasoning, edits, decisions, and policy boundaries. The caveat is important. The report does not list the exact quant, hardware, context length, chat formatting, sampler settings, backend, LM Studio version, or tokens. The headline score was 644 out of 2172, or 29.65%. By category, coding scored 605 out of 2005. The smaller one-point categories were mixed. Data interpretation and quantitative reasoning each landed at 8 out of 12, safety policy at 7 out of 12, planning at 6 out of 12, and source research plus writing and editing at 5 out of 12 each. So the result was not a clean collapse. It was uneven, with a few usable pockets and some serious reliability gaps. The better signs were specific. 2 easy coding tasks passed with full marks: the command line word counter and the slugify function. Outside coding, the model passed 8 of 12 quantitative reasoning cases and 8 of 12 data interpretation cases. It also passed 7 of 12 safety policy cases, including easy credential handling, a medical disclaimer case, and privacy redaction. Some very hard reasoning and data cases also passed, including cash flow, optimization, cohort weighting, and weighted KPI tasks. Those wins matter because they show the model was not simply unable to reason. The coding section is where the model card story meets the hardest local friction. Across 21 coding cases, the total was 605 out of 2,100. Easy coding had 2 full passes, but medium, hard, and very hard tasks were mostly low partial scores, failures, or errors. 5 coding cases errored because the evaluator did not receive valid JSON. That matters for agent workflows. If a local model cannot reliably return exact structured output, it can break tools even when its natural language reasoning sounds confident. The non-coding gaps are just as important. Source research finished at 5 out of 12, with all hard source research cases failing. Writing and editing also finish at 5 out of 12, including misses on easy grammar and fluff removal cases. Planning operations reached 6 out of 12, and one very hard multi-team planning case timed out after 120 seconds. For a coding assistant, these are not side quests. Research, editing, planning, and exact instruction following are part of everyday development work. The model card says Qwopus3.5 27B v3 reached a 95.73% strict pass rate on HumanEval 64 under its manual adjudication protocol. That claim is worth noting, but it does not erase this local result. HumanEval is a coding benchmark, and the local report used a broader suite with different tasks, scoring, inference conditions, and evaluator rules. The fair reading is not, one number beats the other. The fair reading is that model card benchmarks and local workflows can expose completely different failure modes. My verdict is cautious. Qwopus3.5 27B v3 is worth testing if you want a local quant-derived reasoning model with GGUF availability and a developer-friendly path through tools like LM Studio or llama.cpp. But this benchmark does not support treating it as a drop-in local agent brain. The useful path is task-specific testing. Pick the quant you can actually run, test structured JSON outputs, compare against your own coding tasks, and keep fallbacks for research, planning, and difficult multi-step edits. In this run, the promise was real enough to investigate, but not reliable enough to assume. If you found this breakdown useful, like the video and subscribe to Fluid Coding and AI. I will keep testing local models the way developers actually use them, with the wins, the failures, and the caveats all visible.